Welcome to the LRC, where we take September sickness a little too seriously. Regardless, our staff is now back fully in action, so let's get started with everyone's favorite topic, math. Let's start with this. It should be simple enough if you've already watched our previous videos. You would know that these parentheses represent multiplication, so what we have is 9 times 6 plus 7. If you watch our second video, you would know that we do what's inside the parentheses first. So 6 plus 7 would get us 13. And now, we just have 9 times 13. You can figure out pretty simply, either with a calculator or with your big noggin, that this is equal to 117. Cool, right? Okay, so let's add some algebra into it. What if instead of that, we had this? 9 times y plus 7. How do you solve for that? You may not know yet, but using LRC's patented certification, you'll learn in just about 5 minutes. Let's get started, shall we? To answer this question, you need to know about DPMA. What does it stand for? DPMA stands for the distributive property of multiplication and addition, which is just a very long way of saying that you can move this 9 over here to both the y and the 7. What do I mean? This just says that our expression on the left over here would also be equal to 9y plus 9 times 7. How do we know this? Well, let's compare this with some real numbers, shall we? Let's say instead of y we had 6 again. Now this would be saying 9 times 6 plus 9 times 7 is equal to 9 groups of 6 plus 7. Let's solve for that very quickly. If we do all the multiplication, we will find that 9 times 6 is equal to 54, 9 times 7 is 63, and of course 6 plus 7 is 13. Now we have 54 plus 63 is equal to 9 times 13, or 54 plus 63 is equal to 117, which we know is true. From that, we can see that DPMA's property of transferring the numbers in the first parentheses to the second parentheses are indeed correct. Simple enough, right? Now let's go to DPMA's extended family, specifically DPMA's older brother, FOIL. FOIL is pretty similar to DPMA. Let's go over an equation in which you would use it. Let's say instead of what we had earlier, we have this now. 9 plus x groups of 7 plus x. This follows the same principle as DPMA, it's just we have more terms now. For reference, FOIL stands for first, outer, inner, and last. Essentially, all this wants you to do is multiply the first term in the first parentheses by the first term in the second parentheses. Then, you multiply the outer terms for the whole expression, so that would be 9 times x at the end. Then, you multiply the inner terms of the expression, so that would be x from the first parentheses and 7 from the second parentheses. And then finally, you multiply the last two terms of each parentheses. So that would be x in the first set of parentheses and x again for the second set of parentheses. In short, if we apply FOIL here, we will get 9 groups of 7, 9 groups of x, 7 groups of x, and x groups of x. That means that in total, our final answer it will be 63 plus 9x plus 7x plus x groups of x. How do you solve for x groups of x? Well, I will not be telling you, because we've answered this question in a previous video. Try to figure that out on your own. Alright, so is this a final expression? No, not yet. If you look at these two middle terms, you'll see that they are both using blank groups of x, except unlike x groups of x, we know how many groups of x there are. So if we have 9 groups of x and we have 7 groups of x, we can say that there are 16 groups of x. So now this, excluding x groups of x, is our fully simplified expression. Cool, right? Alright, here is some homework that we're very sure you all do. As per usual, the answers will be in the description. Next time around, we'll be showing even more love to parentheses, except this time, instead of taking them away, we'll be adding them. It's just unfair to the parentheses if we constantly take them out, right? Let's try to include them in the group. Next video. Be sure to stick around for that, because that lesson goes hand in hand with this. Until then though, we'll see you around, for real this time.